Hi, I'm Kenry Watson, and today we're going to be putting trigonometry back together. You'll remember from our preamble video that the only things you need to invent trigonometry are knowledge of functions, graphs, and the Pythagorean theorem. And today, we're going to work with the same stuff Pythagoras was working with: triangles. Remember, we are not messing around with triangles for their own sake. We are using triangles as a stepping stone to greater, more circular things. But first, look at this little buddy we've drawn. Notice how its hypotenuse looks suspiciously like an angle ray? That's exactly what I'm talking about. Because we're not super good at angles, we're going to use triangles to talk about them. That's what big math means when it talks about reference triangles. Triangles that are like this one on a graph for angle purposes. Right triangles are the best ones to work with when we're working with angles because we can do the Pythagorean theorem to them. Big math over the years has come up with some words to talk about the angles of a right triangle. In math language, we talk about the ratios between the sides of the triangle because no matter how big the triangle is, or how long the triangle sides are, if the triangles are the same, the ratio of the sides to each other will be the same. It's like how 3/2 and 6/4 are the same thing in fractions. Most math classes ask you to memorize the ratios we're talking about today, and the mnemonic device they use is SOHCAHTOA. Okay, so if this is our reference triangle, SOHCAHTOA tells us that the sine of a given angle is the opposite side over the hypotenuse. But since the opposite side is also parallel to the y-axis, another way of writing opposite over hypotenuse is y over the hypotenuse, or y over r, since the hypotenuse is the radius of the unit circle. So cosine, SOHCAHTOA tells us, is the adjacent over the hypotenuse, which on our reference triangle of angle G, that's a G, is the adjacent side over the hypotenuse side. But you'll notice that on the xy axis, this is also x over the hypotenuse, or r. Okay, and then tangent, which is the final one that SOHCAHTOA gives to us, is opposite over adjacent, which is the same as the opposite angle of angle G, so this one, and the adjacent. So that's, if we said that this is y and this is x, then tangent is y over x. Ta-da! But I have 3 more slots here because there's 3 more ratios that you need to understand when you get deeper into trigonometry. The first one is cosecant, which is written like this, and it's just the reciprocal of sine. So instead of being opposite over hypotenuse, cosecant is hypotenuse over opposite, or the radius over y. So it's this over this. And the reciprocal of cosine is secant, which is hypotenuse over adjacent. So this over this, or the radius over x. And the final one is cotangent, which is the reciprocal of tangent. So instead of being opposite over adjacent, it's adjacent over opposite. So this one over this one, or x over y. So if this is our triangle buddy, and we're trying to find the sine of an angle, let's call it G for Greg. The sine is the same as the ratio of its opposite side to the hypotenuse. So if this is 3 and this is 5, then the sine of G equals 3/5. Wow! You can see on our 3, 4, 5 right triangle that we worked out cosine of G and tangent of G along with sine of G, which we all just did together.
Don't worry if this seems like a lot of stuff to memorize. Once you get to actually use sine, cosine, and tangent on the unit circle and in trigonometric functions, it becomes a lot easier to integrate them into the way you approach problems. SOHCAHTOA is for problems where we deal with triangles directly, and we won't need it as much when we're just working with triangle ratios by themselves. In some of our later videos with Lucas, we'll talk about it a little more, but for now, know that when these ratios are integrated into other trigonometric concepts, they become a facet of your approach rather than a stagnant fact. Good luck!
So sine, cosine, and tangent, and cosecant, secant, and tangent are the ratios that most Algebra 2 geometry pre-calculus classes ask you to memorize. But there's a bunch of others that have been lost to time. There used to be a lot more of these ratios for students to memorize, but many of them have fallen into obscurity as time passed. We're only going to be doing the ones you'll most likely need in your classroom, but I cannot stress to you enough how arbitrary the classroom requirements are. We could teach just half or sine if we wanted, but we won't. So there you go, the three big trigonometric ratios and their partners, who some people consider to be their own trig ratios too. Sorry there wasn't much math to do this time. This is just setting up our vocabulary for the rest. Now that we know these ratios, we're going to apply them to our other triangle knowledge and eventually build that scary looking thing called the unit circle. See you then!